Automatic, Addison.
In this tutorial, we will explore functions and pointers in C++. Okay, let's explore how to use mathematical functions in C++ for robotics. Mathematical functions are essential for performing various calculations in robotics applications. Let's begin by creating a new file called robotmathfunctions.cpp. robotmathfunctions.cpp. And let's type the following into the code editor: #include iostream, #include cmath using namespace standard. Let's do int main, curly braces, double, angle equals 45.0, double radians equals angle, and then we need to convert that to radians. So do angle times m_pi over 180. Do double sine equals sine radians. Let's do double cosine is equal to cosine radians. Let's do cout sine and L. Do cout cosine and L, and return 0. So in this example, we demonstrate how to use mathematical functions to calculate the sine and cosine of an angle. First, we include the cmath header to use mathematical functions. Then we declare a double variable angle and assign it the value 45.0, representing an angle in degrees. To convert the angle from degrees to radians, we multiply it by m_pi, which represents the mathematical constant pi, and divide it by 180.0. We store the result in the radians variable. To calculate the sine and cosine of the angle, we use the sine and cosine functions respectively. These functions expect the angle to be in radians. We pass the radians variable as an argument to these functions and store the results in the sine and cosine variables. Finally, we print the values of sine and cosine using cout. Let's run the code. You should see the values of sine and cosine printed in the terminal. In robotics projects, mathematical functions are commonly used for tasks such as calculating robot positions, orientations, sensor data processing, control algorithms, and motion planning. Let's explore how to implement functions in C++ for robotics. Functions are essential for organizing and reusing code in robotics applications. I'm going to create a new file called robotfunctions.cpp. As we always do, let's do our #include iostream. #include cmath. Okay, this is an added header for the square root function. Do using namespace stud. And let's do function declaration double calculate distance double x1 double y1 and double x2. Okay, and let's add double y2 as well. So now we'll do int main do double distance is equal to calculate distance 0, 0, 3, and 4. Do C out distance. 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 Indel. Return 0. And let's create our function definition. Function definition. And we're going to create a function to double calculate distance. Distance. And let's do double. Let's do all this stuff in here. I'm going to copy and we'll paste it in. Okay. And let's do curly braces. Okay, and first we are going to do double dx is equal to x2 minus x1. Let's do double dy is equal to y2 minus y1. And let's do double distance is equal to square root of dx times dx plus dy times dy. So return distance. There we go. So in this example, we demonstrate how to implement a function to calculate the distance between 2 points. First, we declare the calculate distance function before the main function. The function takes 4 parameters, x1, y1, x2, and y2, representing the coordinates of 2 points. It returns a double value, which is the calculated distance. In the main function, we call the calculate distance function with the coordinates 0, 0, and 3, 4. The return distance is stored in the distance variable and then printed using cout. After the main function, we provide the function definition for calculate distance. Inside the function, we calculate the differences in x and y coordinates, dx and dy. Then we use the distance formula, the familiar Pythagorean theorem, to calculate the distance between the 2 points. Finally, we return the calculated distance down here. Let's run the code. And we get distance 5. You should see the calculated distance printed in the terminal window. In robotics projects, you can use functions for various purposes, such as calculating sensor data, controlling robot movements, implementing algorithms, and more. Let's explore how to handle pointers in C++. Pointers are variables that store memory addresses and allow you to manipulate data directly in memory. Let's create a new file called robotpointers.cpp. And type the following into the code editor. Using namespace stood. And let's do int main curly braces and int robot ID equals 42 and int pointer. So we use the asterisk right there, and equals ampersand robot ID. Okay, and let's do cout robot ID. Robot ID indel. Cout pointer value PTR indel. And do cout dereferenced pointer PTR. Okay, so we use the asterisk to dereference the pointer. Now let's do asterisk PTR equals 99 and cout. Don't worry, I will explain all of this afterwards if you're getting confused of what these asterisks are and ampersands. Updated robot ID and robot underscore ID and L and return 0. So what is all this new stuff we've added? So in this example, we demonstrate how to handle pointers to manipulate data in memory. First, we declare an integer variable robot ID and assign it the value 42. Then we declare a pointer variable PTR and initialize it with the address of robot ID using the operator ampersand, the address of operator ampersand. So this ampersand means address of robot ID. So this ampersand operator retrieves the memory address of robot ID, the memory address of the variable, okay? And our pointer variable, we use the asterisk to initialize it with the address of robot ID. So that's how you do the pointer variable, using that asterisk. We print the value of robot ID, the value of PTR, which is the memory address, and the dereferenced value of PTR, okay, using the asterisk. The asterisk operator, when used in front of a pointer variable, like we're doing here, retrieves the value stored at the memory address pointed to by the pointer. This is called dereferencing. Next, we use the dereference operator, this asterisk, to modify the value at the memory address pointed to by PTR. We assign the value 99 to asterisk PTR, which effectively updates the value of robot ID. By dereferencing PTR and assigning a new value, we are changing the value stored at the memory address pointed to by PTR, which is the memory address of robot ID, which is what we did here. So you might want to repeat my explanation again and again and again if that wasn't clear, so that you can understand how we create the pointer variable, how we initialize it with the address of the variable robot ID, and then how we dereference it right here. And then how we dereference again to modify the value at the memory address pointed to by PTR. Okay, and then finally, we print the updated value of robot ID to confirm that it has been modified through the pointer. So now let's run the code. Right click, click Run Code. So here is what you get. You should see the original robot ID of 42, the pointer value, which is the memory address, the dereference pointer value, which is the same as the original robot ID, and the updated robot ID printed in the terminal after the modification using the dereferencing of the pointer variable. In robotics projects, pointers allow you to directly access and modify data without needing to move or copy it, which makes programs run faster and use less memory. Let's close this out. Let's learn how to manage exceptions in C++ for robotics applications. Proper exception handling is important for robust and reliable software systems, especially in the field of robotics, where errors can have significant consequences. Let's start by creating a new C++ file called exceptionhandling.cpp. And type the following into the code editor. Double, divide, double A, double B. Okay, if B equals 0, okay, we'll do a throw stood runtime error division by 0. And then do return A over B. Int main, do try, do double result equals divide 10, 0. Okay, don't worry about what all this is. I will explain it in a second. Stood cout, result, and let's do result, stood end line. Okay, let's go down here and let's do our catch. This is where we catch any unexpected errors. We do const stood exception ampersand and then E. Stood error E dot what? Stood end line. After that, we do return 0. Save. So in this example, we define a function, divide, that throws a standard runtime exception if the denominator is 0. In the main function, we wrap the call to divide in a try block and handle any particular exceptions in the catch block right here. So this code will run, and if an error or exception is thrown, it'll be caught in this catch block. So let's run the code. And you should see error division by 0 printed in the terminal, as we intentionally passed 0 as the second argument to the divide function. And you know, you cannot divide by 0. So, proper exception handling is important in robotics applications where unexpected situations or sensor failures can occur. By using exceptions and handling them appropriately, you can ensure that your code gracefully handles errors and maintains a consistent state, preventing potential damage or safety issues. Thank you, and I'll see you in the next tutorial. Keep building.